Hello and welcome. My name is Flower Grills. This is episode 3 in Max MSP user guide tutorials, and let's get right into it. So last week we looked at this adjustable oscillator. We looked at how we can change the frequency and amplitude smoothly. Let me just quickly demonstrate. Yeah, if when we turn the amplitude, we could hear the clicking, and same with the frequency. It's that weird sound. So how do we get rid of it? Well, we looked at line tilde, slowly telling both the frequency and the amplitude to change with this variable here. There's no more clicking, there's no more zipper noise, right? That's what it was all about. This week we're expanding this concept a bit more. This is what it looks like. It's called a wavetable oscillator. And the main thing to focus on here is the cycle tilde. So we've looked at cycle here before, but we've not actually used it as a wavetable. Well, we have, but we've not loaded it with our own samples. So that's what this week is about. So you can see here there's a new object called buffer tilde. Well, if we double click, we can see what's inside here, but we can also option click and see the tutorial. And basically you can store audio samples in this buffer. It can adjust to how long the sample is. Yeah, it's essentially a memory space. Using these messages here, you can give it commands. And what they've done in this tutorial is use this buffer to load this sound, which comes pre-installed with Max. So it reads GTR 512. The 512 stands for how many samples is in it. It's 512. That is stored in the buffer. So again, if we lock the patch using command click and then double click the buffer, we can see that they have called this wave rich tone. And then what they've done is reference this same buffer in the cycle tilde. So that's really what's going on here. So let's give it a play, and then I'm going to explain. So this is what happens when you play a note. If we go from left to right, I'm going to explain each one. So we can play each message in this tutorial. These are messages with envelopes, which are going to this line object. And it's saying start at 0. Like you have to be at 0 instantaneously at 0 milliseconds. That's what the comma means. This is also in the tutorial. And then it's just however many pairs of numbers you want to put into the message. So it starts at 0 amplitude at 0 milliseconds. Then it goes to 1 amplitude after 5 milliseconds, and then it goes to 0 amplitude after 15 milliseconds. I know it's a bit confusing at first, but it's just made up of pairs. This looks like a random bunch of numbers, but it's the same here. You start at 0 milliseconds, then you go to 1 amplitude, and it will take you there over 100 milliseconds smoothly. Then you will stay at 1 for 800 milliseconds, and then you will go back down to 0 after 100 milliseconds. So it's essentially an envelope shaper. If you imagine it like an envelope, it's going up, then it's staying there for a while, and then going back down. If you're familiar with synthesis and using envelopes like attack, sustain, decay, release, then it's the exact same thing here, but with numbers. And what this is doing is this is sending envelopes to each one of these generators, shall we call them, for different types of waveforms, so that they trigger sounds, stay at a certain amplitude, and then they finish. And together you create this sort of rich sound, which doesn't really sound like a specific instrument, but just sounds more than the combined sound of each individual sound if you play them. They sound quite simple. So that's what's happening here. This is so this one is, these two are being fed into the line tilde object, and that is being combined with the noise here. So remember when we talked about this having to be an audio signal, it's sending audio samples, at 48,000 hertz per second instead of a normal line object, because a normal line object just sends at the usual rate that Mac sends data, which is too slow for sound. So that this, the operand, right, the right side of this equation is essentially how much the noise tilde here is being amplified, and it goes from 0 to 1 to 0, but very slowly with a lot of float numbers. Then we've got a sawtooth wave. So we've not seen phasor before, but you can use phasor to generate saw waves, and the phasor is also being fed envelopes here. So if we play them, I'm not sure what these B1, B2, B3 messages are here for, because they're not actually connected to this button up here to play the note, right? As you can see when I'm highlighting it, it's just connected to the A1, A2, A3 messages. So I don't know what Cycling 74 wanted to show here. Maybe just a different variant of the sound, that this is what happens when you send different messages to the line object. Now, the reason why this phasor tilde sound is being first multiplied by 2, right? This is the times tilde object, and then it's being subtracted by 1. This is the subtraction or minus tilde object. It's essentially to turn this from a unipolar to bipolar signal. Phasor generates a ramp signal, as you can see here, from 0 to 1, and in order to get it from -1 to 1, you have to multiply it by 2, right? And then take away 1. Here, I can show you the example, and then I'm gonna just signal this through here, and you can see. So it's multiplied this by 2, making it bigger. Its range going now from 0 to 2, and then -1, so now it's going from -1 to 1. So that's all that's happening here. If you want to generate signal, then it's better for it to be from -1 to 1 than from 0 to 1. 0 to 1 is great for controlling other things. So yeah, that's the reason behind that. And lastly, we have the cycle tilde. First of all, let's hear what the phasor sounded like. And then we've got the cycle. First message here is actually more complicated, because we've got 1, 2, 3, 4 lines in the envelope. So going to 1 amplitude in 20 milliseconds, then going back down to 0.5 in 80 milliseconds, going further back down to 0.125 in 500 milliseconds, and then back to 0 in 400 milliseconds. So yeah, you can see that tail is quite long there. And then this one's louder because it goes to 1 and stays at 1 quite long, as you can hear. That's the result of playing all these A messages together. Not a particularly pleasant one, but yeah, it shows you how you can generate sounds together. And now, to really hammer the concept in, I had a play around myself. So here's my buffer object. These are all the same sort of objects as here. I decided to call it poor tone instead of rich tone. What you can do, as we've seen with the buffer reference here, you can send it messages, and you can send it a replace message or read. So I send it replace, and then I can put anything into it. It just has to be something that... So to explain it, the cycle tilde, right, it's a wavetable. It goes through 512 samples, and then it repeats. And you can feed cycle tilde any sound you like. That's the point of this tutorial. So instead of using this guitar 512, I replaced this, and I found this rhythm bass. To troubleshoot, you will not hear the difference at first. So you have to turn off the audio engine. It's behind my webcam right now, but it's in the bottom right. And turn it back on. And then cycle tilde is going to read the buffer again and read the actual wave that it's supposed to. And then, let me show you. So I've connected an integer object here, and you can change how many times per second cycle tilde reads the wavetable. So it's quite fun. Let me show you. Sounds like a robot being tortured. If you need that kind of sound. I think this one worked quite well, and you can see that it's loaded it in. Right, if it's at 0, then it's reading the wavetable 0 times per second, then 1 times per second, as you can see here. That's pretty fun. You can experiment yourself. You can fill buffer tilde with whatever sound you want. Just remember, it has to start instantly, and it has to be quite rich, or just something that you'll be able to hear. Because I've tried to fill this with vocals or with something that's quite gentle, and then remember this is something that repeats multiple times per second, so it's not going to read the whole sample. It's going to read the first 512 samples and then repeat. So that's it for this video. I hope you found it useful, and I'll see you in the next one.